Hello all. Today we are solving LeetCode problem number 3296, minimum number of seconds to make mountain height 0. So basically you were given an integer mountain height denoting the height of mountain. You are also given integer array work times representing work time of workers in seconds actually. The workers work simultaneously to reduce the height of mountain for worker I. The decrease To decrease mountain height by x, it takes work times I plus work times I multiplied by 2, and it goes on till x seconds. So for example, to reduce mountain height by 1, it takes work time I multiplied by 1 seconds, and to reduce by 2 it takes similarly the 1 and added with work times of I multiplied by 2, and it goes on based on the seconds. So return an integer representing minimum number of seconds required for the workers to make the height of a mountain 0. So basically this is the question. So before writing or before explaining the question let me draw the diagram. So we are having a distribution, so where the mountain is given, uh, for example the height h. So now we are given workers as the list actually. So from this you have I plus 1 and I plus 2, or instead rather than explaining the question in the terms, I think we can use the example for it. So we are given mountain height as 4 and work times as 2 1 1. So you have 2 1 1. So all these timings are for three different workers. So now we are given the mountain height which is equal to 4. So now to reduce the height from height by 1, the time consumed by one worker, that is equal to work time work timer of I multiplied by 1. So if it is by 2, then it is work timer of I multiplied by 2. So similarly, not by 2, also you should have work timer of I multiplied by 1. So if h is decreased by x, so in this case what happens here is work timer of I plus work timer of I multiplied by 2 plus, and this again work timer of I multiplied by x. So this is how the time is being calculated. So t is equal to this. So in terms of example, for worker 2, by 1 it takes, uh, maybe I can write implies time is equal to 2 multiplied by 1. So for by 2, in case 1 by 2, it takes t is equal to 2 multiplied by 1 plus 2 multiplied by 2. So here it takes 2 seconds, here it takes 4 seconds, and by 3 it takes t is equal to 2 multiplied by 1 plus 2 multiplied by 2 plus 2 multiplied by 3 is equal to 6. Sorry, this is not 6. 6 plus, then this is 10, right? 2 4 and 10, yeah. So it goes on based on the x x unit of reducing the mountain. So based on this, you can come into a observation here. You can take the work time, which is this 2. So work time, then you are getting 1 plus 2 plus 3, it goes on till x, right? So this is nothing but this can be written as work time multiplied by x into, not, yeah, this is x, right? X into x plus 1 by 2, sum of natural numbers. So this is the observation to find the time based on based on the workers given. right? One provided the worker time is given in the array. So from this you can form the available distributions to complete complete reducing the mountain to zero from height. So based on this example, if you see, there is one particular distribution, combination of distribution given, because all the workers work simultaneously. So worker 0 reduces the height by 1, worker 1 reduces the height by 2, and worker 2 reduces the height by 1. So in this case, worker 0 is 2 seconds, so you get 2 multiplied by 1, which is 2 seconds, and worker 1 you get 3 seconds. Why? Because 1 multiplied by 1 plus 1 multiplied by 2, which is equal to 3, so you get 3 seconds, and again you get similarly 1 second. So now you the based on the question, return an integer representing minimum number of seconds required for workers to make the height of mountain zero. So the you get all these possible combine this distribution. So among this three is the answer which we are going to return it, because since the workers work simultaneously, the minimum time required is maximum of 231. So it is due to that reason you find that particular distribution which is the minimum one, and then you return maximum of all those three values found as the output. So so you can see here the terms minimum is required within this uh, minimum time required based on this distribution, right? So this is something, a hint which we can use to check if the problem could be solved using binary search. So now, if thinking about this, yes, we can solve using binary search. And how? Because you know that the workers time 211, this indicates the time or amount of work done by the workers, right? So these two workers complete in less time, and these worker takes consumes more time to complete this work, right? So in this case, this is the maximum value, and when you are substituting in this particular equation, work multiplied by x into x plus 1 by 2, equation A, you get time is equal to 10, right? And the minimum one will be starting from 0. So now you have a you have a range, right? So you have the range which is range from 0 to 10. So there lies a time t for which it is minimum. This is the answer which we have to return. So since the range is there and the task is to find the minimum value, yes, you can solve in binary search. But in this particular solution, we are I'm not going to solve using binary search, because that is, you will be using this mathematical equation for finding the distance actually. So that's little bit complicated, but it is easy when you are going through it. But here in this particular problem, I have planned to solve use the heap, and into a heap using heap. But this is a very different and intuitive solution, and I found this very interesting. And honestly, I did not come up with this solution, but this is very interesting. So that's the reason I wanted to go with that. So with that, let us jump into this particular solution. With that, we use a heap which can be called as h, and inside which we store a tuple which will have accumulator, result, and followed by base work or base value and the count, the next count basically. So this is how the tuple is structured, and we are going to append this into the heap first, because Python has min heap, and the idea is to use the minimum among the formed tuples. So basically in the first example we have 2 1 and 1. So this forms the first tuple. Now since we do not have the accumulated value from the previous one, so it is due to that reason when initializing this, you will initialize with the base value. So you have 2, and the base work is also 2, and the next count, now the first count is 1 and the next count is 1. Based on the distribution, if you see, you have work done multiplied by 1 plus work done multiplied by 2, and it goes on, right? So the next count will be tracked here for that particular purpose, and the next count is 2. So now similarly we have 1 1 2, again 1 1 2. So the heap contains 1 1 2, that's the minimum one, and followed by 1 1 2, and again followed by 2. This is 2 2 2, yes, right? So this is the heap which we are having. So what we will do is we will iterate till the height becomes, I mean, height is reduced to 0. So which means we have the height is equal to 4. So we have 4 iterations, right? So now just follow with me so that you can understand the actual idea how things are working. So now what we do is we pop the element which is the minimum value, so which fetches us 1 1 2 here. So now what we do is we update the accumulated value, right, and update count. So based on this, the accumulated value is nothing but you have the already existing accumulated value added with the base multiplied by count. So you may wonder how this is coming, right? So in this equation, if you see, you have work time multiplied by 1 added with work time multiplied by 2. So that is exactly this actually. So you have the work time as the base, and which is multiplied with the count, that gives the new value, and you have the existing value in the accumulated. So when you are adding this new value inside this accumulated, you get the accumulated value. So because of that, the new tuple formed, and also update count is just increment by 1. So now the new tuple which is formed will be you have 1 1 1 here. So 1 plus 1 multiplied by 2 is 2, which is result in 3, and the base count remains same 1, and the next count becomes 3. So you get 3 1 3. So now you push this into the tuple. What happens here is you get this removed and this comes up, and next thing is 3 1 3 in the bottom. So one iteration is done. In the next iteration again you will repeat the same thing here. So what happens here is you will have update the next value. This will be removed, this will be popped, and you update with 313 again. And one thing I forgot to inform here is whatever may be the accumulated value, that we have to add in the result. So result first it will be 1, right, when we are popping it, and then we have this result, and next while we are popping it again the result remains 1. So 2 iterations are done, result is equal to 1 because of the accumulated value whichever we popped. So what happens here is 2 iterations is done. Now comes the third iteration. So result is 2, and you have 2 2 2. So this becomes accumulated value, which is 2 multiplied by 2 is 4, plus 2 which becomes 6, plus 2, and this becomes 3. So you add this 6 2 and 3. Now you have, this is popped, 3 iterations is done, right? 3 iterations is done, this 3 are popped, and you have 313 313 and 623. So you pop this 313 again, so which means you have 313 and result becomes 3 here now in the fourth iteration. So updating this 3 plus again 3 multiplied, no, this should be 3 multiplied with 1. Yeah, 3 multiplied with 1. um, yes, so this becomes 6, 1 and 3. So you update this into the heap 6 1 3, and this is popped, so 4 iterations is done. Now you can look at the result which has 3 as the value. So now the time is done, I mean the iterations is done, so you come out of the loop, whatever value is it in the result you return result equal to 3. So this is how you will be solving this problem, and the time complexity will be since you're iterating through this for loop, it takes big O of n times multiplied with using heap, it consumes n, I mean log n times. So basically the time complexity in total will be big O of n log n because of the heap operations along with the linear iterating through the given array. So this is the time complexity. So with this idea, let us go ahead and code this up. So let us start with creating the heap. Let that be h, and we have to fill the heap with the initial values, right, which has the tuple of accumulated result with the base value along with the count. So based on that, for I or for val in worker time. So from here, heap q dot heap push. So we push inside heap h, and the tuple or the value, and initially it will be value for the base value as well. Every time it will be value for the base value, and initially the accumulated result will be just the value itself, and we start the next count which will be 2. So let me mark it down, or yeah, so the tuple should be accumulated result, then base value along with count. So now we filled the tuple initially, and now the time is to for reduce the mountain height, and till reaching 0 we iterate in the loop, and then we use to modify the tuple based on modifying the minimum tuple whichever is there, we are popping it out and updating with the value and pushing into the heap. So for I in range mountain height, so now we have to take it, so which will be accumulated and base followed by count is equal to heap q dot heap pop h. So now that we have popped the value and each value is here, so using which we will be making the updating the new tuple and then update it, and along with that we will store result is equal to accumulated, and now heap q dot heap push h, and here for the next the new accumulated value which will be calculated by accumulated plus base and multiplied with count. So this is the next one which is added to this accumulated value. So now we have to have the base, so base will be same, and along with that count will be incremented by 1, so count is incremented by 1. So now we have we will repeat the same thing till we I mean till the mountain height is getting reduced to 0. So after that, return result. So let me run it and submit it. There we go. Thank you.